Okay, we're going to start doing some G code. It's the code that drives everything: 3D printers, laser engravers, mills, printers, vinyl cutters, anything that moves that's a machine has G code in it. So to know G code is really helpful. First thing we're going to do is we're just going to make a rectangle with G code. They've got a G code generator which generates the code, so we don't just sit there and tediously learn it. There's a rectangle right here. We're going to go from point 2. You have clicked on point 2 right here. Go up in the top, off of. So this is kind of your machine coordinate where your mill would be. We're going to go off of that to set our tool offset or work offset, where our tool is going to line up on our work. So we're going to go off of 2. The tool is going to be outside of the rectangle. So if we go in here and we click on the cutter compensation that I put in Google Classroom, the only exact point on your cutter is the center of the cutter. So you're going to have to line the center of the cutter up with the corner of the workpiece, and then you're going to have to push that cutter off. It's half of the cutter over and half of the cutter down so that it lines up on the edge of the piece so it can actually cut the piece. So all these flutes right here are going to be cutting the piece. If you just try to cut right on the top, it'll cut into the piece. You're trying to bring the piece down to a certain amount. So we're going to go back and tool outside a rectangle. So what you saw right there on this is the tool will be outside the rectangle. We're going to go clockwise. Side A is going to be 3, side B is going to be 5, tool diameter 1. Depth of cut, we'll just leave it at 1 and 1 because I have to click on this a million times to get it to work sometimes. It's working better earlier today. We're going to go in and we have to set a negative 0.5 on the XC distance and a 0.5 on the YC distance, because if I were to plot my cutter right on top of this corner, I would have to go negative 0.5 to get it to line up on the edge. So that'd be the radius, half of 1. And then I'd have to go around this corner, and then I'd have to go a positive 0.5 to get it to line up on this edge when it's going in the Y direction. So kind of hard to understand, but that's your cutter compensation. Say if Z above surface it'll be 0.5 above the surface of the workpiece or the rectangle. So we created this G code, which basically says rapid move to Z of 0.5, rapid move to the corner of the workpiece where it's offset like we're talking about. It's going to start plunging in to a -1 on the Z with a feed rate of 50. It will then complete the rectangle with a feed rate of 50. So this is just your regular movement where the cutter should be going. We haven't done any speed, so it's not actually rotating in this code yet, but it goes around the rectangle, and then at the end it retracts up to a 0.5 with a feed rate of 70, and then it goes back to where it started, and then M30 means that it stops the code. So what we're going to do then is we're going to take this code, we're going to right click, copy it, we're going to go up to our NC viewer, which is linked in Google Classroom right here, and we are going to just go ahead and copy that code. Oh, dang it. Paste it in there, and I'm going to have to repaste it because I'm having problems. Copy and paste it in there, and then we will press plot, and then that shows that we just made a rectangle. This is the G code for a rectangle. You don't have to know how to write this out longhand. I don't like writing out longhand, but you do have to know kind of what it means, what it is. There's going to be some M codes that we probably throw in here later, but here's how you just plot out a basic rectangle.